and to help you not to fool yourself. That's the goal of this time. Right? It's good to know the truth now because there's 2 days to prepare. Because the truth is coming out on Wednesday. So it's good to know it in advance to prepare, to make it a happy truth on Wednesday. All right, so give that a try. Cotan. And notice part 1. Oh, it's off the screen now. Notice part 1 is no calculator at all. Question?
So I was like, how does that work?
Yeah.
Part 1, part 2.
Yeah, exactly. Try that one. Try cotangent, pi over 3. You see the multiple choice options? Give it a try. Give me a second. Okay, so how do we do? I'm going to go to fresh screen. How do we do? Here's number 1. Oops. Oh, I'm not going to do anything in the. Okay, so number 1. Cotangent of pi over 3. That's cotan of 180 over 3. That's cotan of 60 degrees, right? So this is what I would do with no calculator at all, by hand. Cotangent of 60 degrees is what they're asking me. How do we actually find that? Let me draw myself a little unit circle. You'll have one on your sheet already. Where's 60 degrees? Remember, we have the 3 dots in every quadrant, right? We have the one right in the middle, which is always 45. This is 0 here, you know. 30 is here and 60 is there, isn't it? Good. So they're asking me 60. So that means from the origin, over a little bit, up a lot, huh? To get to 60. You go over just a little bit, up a lot. Now, what do I mean little lot? Well, we had those 3 numbers. 1, 2, you know, the root of 1, root of 2, root of 3, all over 2. That was the small, medium, and the large, huh? Root of 1, 2, 3, over 2. Now, the square root of 1, that's just, you know, we get rid of that root. The others must stay, because root of 1 is just 1. So there's the 3 numbers, right? A half, root 2 over 2, and root 3 over 2. Small, medium, and large. So when I say it's over a little bit, that's the half. Up a lot, that's the root 3 over 2, isn't it? And the one in the middle, the 45s, they're the ones that use the medium, root 2 over 2. The other spots all use the small and the large. So that means this dot here, right here, the 60-degree dot is over a half, up root 3 over 2. So what does that mean? Well, that's the cosine and the sine, isn't it? Remember the x, they're backwards order, huh? We would normally think of them as sine first, then cosine. But it's backwards order. It's a comma there. It's cosine first and then sine. So, what? Now they want cotan. How do I get cotan from sine and cosine? Yeah, do you have those on your 3x5 card? Those, you know, tangent, remember. Here, I'll move over here. Tangent is sine over cosine. You want to have that in your 3x5 card. And then cotan, being the upside down of that, is cosine over sine, huh? So you want to have those basic definitions on your 3x5 card. And you might wonder, like, well, how do I know what type? Sometimes, good question. Students ask, like, Mr. Aaron, what should I put on my 3x5 card? Honestly, I don't know off the top of my head. What I would do is today, as we're going through the practice exam, I would even have a sheet out, like a side sheet, and write 3x5 card. You know, right over in the corner of one of your note sheets today. And because it kind of depends from person to person. Some things you know cold and you don't need to put them on your 3x5 card. Some things you don't. So like whatever you need as we're going through the practice exam. Because this is showing you everything I'm going to put on the real exam on Wednesday. So anything you need as we're going through this, you'll need on Wednesday. So I like right now I would probably say, oh, I need those basic definitions. So I'd write sine, cosine, tangent, and write tangent is sine over cosine. And then I would write the opposite, guys, which is what? Cosecant, secant, and this one's cotan. I'd probably have that right now, and I'd write a little note. 3x5 card, have those basic definitions for sure. You know what I mean? The cosecant is upside down, secant is upside down, cosine, cotan is upside down, and tan is sine over cosine. I'd probably have that, just because of how I've seen I need it on problem number 1. So as you need things, plop them down on your 3x5 card. All right, let's keep going. So anyway, so cotan being cosine over sine, it's going to be a half cosine. Here, I'll write it over here. So it's cosine, which is a half over sine, which is root 3 over 2. Cosine over sine, a half over root 3 over 2. Now, we can't leave our answer that way, you know that. And so what do we do to simplify that? What do you do when you got like a big old fraction over a fraction? Yeah, because dividing is upside down multiplying like we talked about, huh? To divide by this root 3 over 2 is to multiply by the upside down of it, huh? Everybody got to just grab that and flip it upside down and made it times because dividing is upside down multiplying. So the one that's on the bottom, it's got to be the one on the bottom, flips up, doesn't it? Because dividing is upside down multiplying. And then you know you can cross cancel. So you get 1 over root 3, which is basically the answer, but we can't leave a root in the bottom. So multiply top and bottom by root 3. And we get root 3 over regular 3, right? Because 2 roots in the bottom is a regular 3. And there's the answer. Hopefully that's one of the options there. Root 3 over 3. Go back and look for it. Root 3 over 3. Root 3 over 3. There it is, D. Good. Questions I can answer on that? So you don't need a calculator for that, huh? Just need the unit circle knowledge. All right, I'll move on. All right, secant negative 3 pi over 4. Okay, so I would again convert that to 180. I'd plug in 180, sorry, for pi there. So put in 180 degrees. Now there's more tricky. How about I do it the long way, and then I'll show you some tricks after. Because there's a couple tricks where you could just go snap, snap, problem done. The answer to this problem is negative root 2 over 2. Because of the tricks. I'll show you. Anyway, let's just do it longhand first off. So this would become secant of negative 3 times 180 over 4. Like that. Good. So, right, because pi is 180. So whenever we see pi and 180, that's the bridge between the two worlds, huh? Now, you will have to be able to do this by hand without a calculator. That's not expecting too much, right? 3 times 180 divided by 4? Right, good, all that stuff? So, you can multiply first. So 3 times 180, 0, 24, 540. Then you got to divide by 4. Right, so I multiplied these two. I did 3 times 180, got 540, and then I got to divide by 4. So multiply by 3, divide by 4. So 4 into 5. Remember how to long divide by hand, sort of? Been a while? 4 goes into 5 one time. I don't long divide by hand very often either. Bring down the 4. What's that? 3 times? 12, 20, 5 times, huh? And that's going to be 20, and we're done. So 135 degrees. So this becomes secant of minus 135 degrees. All right, let's go to the unit circle. Now here's 0 degrees. How are we going to find negative 135 degrees? What do you do for negative angles?
Add 360.
You could add 360. Or you could just do the negative angle. Either way, totally good. Yeah, we have a lot of options now, don't we? Yeah, negative angle means it goes down first instead of up, huh? So I could just go down 135 degrees. Well, where's that? That's 90 and 45. I mean, both negative, but 90 and 45 is 135, isn't it? So here's negative 90, here's down 90, and then so it's right in the middle of the next quadrant. That's negative 135 degrees. Does that make sense how I found that? Because it's 90 and 45 more.
Yeah.
Good. So it's right here, negative 135. Now let me draw that again. So it's right here. That's negative 135. So now, what does that mean about It's back and down medium, huh? It's right in the middle. All that one's smack in the middle. 45 is halfway, half a 90. So it's right in the middle. So that's the medium. So remember, it's root of 1, root of 2, root of 3, over 2. They're all over 2. Small, medium, large. So it's the medium, isn't it? So it's back, root 2 over 2, down, root 2 over 2. So it's always from the origin, back and down. They're both negative, huh? Because left is negative, down is negative. And they're both medium, right in the middle. The medium always goes with the medium in the middle, remember. So that means the coordinates are back root 2 over 2, down root 2 over 2, cosine, sine. So it's backwards order, right? Cosine first, then sine. Now what was the question? It was secant. That was the original question, secant. So this is where you want to have on your 3x5 card, secant is upside down of cosine, or maybe you already know it, just cold. Secant is upside down of cosine. It's 1 over cosine. So you got to take the cosine answer and flip it. 2 over root 2, like that. Negative 2 over root 2. Oh, so I think I said the upside down answer a minute ago.
You did.
Yes, it's really this. Now, we can't quite leave it that way. Right? Can't leave it. Why not? Got a square root on the bottom. Got a square root on the bottom. So let's multiply top and bottom by root 2. By the way, if you want a trick, did I already show this trick to save time here? The 2, anytime you got a root on the bottom with the same number on the top, do you realize that 2 on the top could be seen as root 2, root 2? Because that is 2, right? So then one of these cancels one of these. And the answer is just minus root 2. Now, if that's confusing for you, I'll do it the long way. But you will save a little time that way. But it's no big deal. It doesn't matter. Just multiply top and bottom by root 2. We'll do it the old-fashioned way. 2 root 2 on the bottom, root 2, root 2. Plane 2, then they cancel. See, same answer. Negative root 2. Is that good? Just multiply top and bottom by root 2. The bottom 2 root 2's make a plane 2. These 2's cancel, minus root 2. But the quicker way is just to recognize that 2 already holds 2 root 2's, doesn't it? So one of those root 2's cancels with the one on the bottom. There's just one extra root 2. Save a little time and effort that way. All right. Either way, there's our answer. Hopefully that's there. Is that one of the answers?
Yeah.
Minus root 2. Wait. Oh, I'm looking at the wrong one. Yeah. It's B, huh? So B it is. Minus root 2. Questions on that one? Is that okay? And I'll show you the quick way also. But is that okay? How I got there? I'm glad to answer. Today's the day. Please speak up if it's the last chance before Wednesday's test. All right. So yeah, now I said you can do this super quick. How can you do this super quick? Let me redo it. Number 2, secant of, what was it? Minus 3 pi over 4. 2 things you could know. First off, secant is upside down a cosine, isn't it? So this is 1 over cosine. That you know. That's not an amazing trick or anything. But then the trick which you may or may not remember, we covered it, but remember how you never have to leave negatives inside any trig function if you don't want to? Remember how we learned that? I mean, we learned a lot of things in the last 2 weeks. But that was one of the facts. We learned that sine of a negative angle or tangent of a negative angle, the negatives come to the front. Right? For sine and tangent, the negatives come to the front, so you don't have to leave them in there with the angle. And then cosine was a different story, though. I don't know if you remember. What did the negative angles do plugged in for cosine? Comes out positive, actually, and just vanishes. And these guys are always the same as their upside down functions. So whatever's true for sine is true for his upside down cosecant, and same with the rest. So therefore, so in other words, for cosine, he's the special one. Negatives inside just poof, vanish for cosine. So that's what they also do for secant. Because secant is upside down in cosine. So where's this negative go? Bye-bye. It doesn't matter. It'll be the same answer as if you just do the positive angle, is what that means. That'll always be the case for cosine. So you don't have to know that. You could, I did it without using that, right? I just did it. But it will save you time. If you just go, oh yeah, secant, upside down to cosine, never need to leave negatives, right? All negatives inside a trig function, all negative angles can be removed to the front. For sine and tangent, they just literally move to the front, and then there's a negative in the front. For sine and tangent, right? Sine and tangent end up having a negative in the front instead of on the angle. Cosine, the negative just vanishes completely, and there's only positive in the front. And then you could take this and just look on the unit circle, huh? You could just say, no, I'm just going to go to the unit circle if I can find it here. Where is the unit circle? Let me see. I think it's way back in my notes here. Oh, there it is. Boom. Yeah, so then you can just go, okay, so I'm just going to look for regular 3 pi over 4. Because this thing only has positive angles, right? 3 pi over 4, there it is. Cosine sine, boom. Negative root 2 over 2. So there it is, 1 over negative root 2 over 2. Flip it up, negative 2 over root 2. Get rid of the root, boom. So, a little quick. Whatever you want to do. So, cotan, that one says, I'll make it a little bigger here, number 4. So I'm skipping number 3. That's okay. It says cotan and negative, power 6, right? Yeah. All right. What can we do with that negative sign? Negative on an angle? Yeah, it always comes out of there and either lands in the front or vanishes. So if it's sine or tangent, or they're upsides down, it comes to the front. Yeah, and this is cotan, so just pull the negative to the front. If you want. You don't have to, but I think it might be easier. Just yank it to the front, right? For sine and tangent, they just come to the front. For cosine, it vanishes. We never have to do negative angles again. All right. So you pop in your 180. Keep going. Let me give you a second. See how fast you are now at this thing. Can you whip this out? Exam on Wednesday. I want to not surprise you. You'll have an hour, not the whole period. You don't get the whole 2 hours. Hour and 15. Hour and 15 minutes. So what I'll do is I'll come to class, and for the first half an hour, I'll probably start the new section, which you'll hate and wish I didn't do. I wish I didn't have to either, but we have limited time. So I have to use our time for your benefit. So I'm going to have to start chapter 2 for the first half an hour on Wednesday, and then I'll give you the exam. So you'll have an hour and 15, but I want to not surprise you. So as you go over the practice exam, make sure you can do all 20 problems in an hour and 15 minutes. Most people have no trouble in the first exam, but there's always a couple. So I want to let you know, so you're not surprised. Not a whole 2 hours. Hour and 15, that's all of our exams. Every one of our exams will be an hour and 15 minutes. It'll be the same deal all the time. They're all designed for that, although some that's harder to do than others. So minus the cotan 30. Go to the unit circle. Find our 30-degree angle. 30 degrees, where's that one? That's the one close right here, huh? 30 is right there, which means it's over a lot, it's up a little, huh? Remember the small, medium, large? Root 1, root 2, root 3. All over 2. So it's over a large, root 3 over 2. I'm getting kind of scribbly there. Root 3 over 2. Up a little, only up a half, huh? It's over the large, up a little. So that means over a large, up a little. Cosine, sine. And what are we doing? We're doing cotan. So what's minus cotan? What's cotan? What over what? Yeah, because tan is sine over cosine. So cotan is cosine over sine. It's a negative. Don't forget about that negative in front. So it's negative cosine, root 3 over 2, over sine, a half. You know the deal. You grab the one in the bottom and you flip it up because dividing is upside down, multiplying. Negative root 3 over 2 times 2 over 1, right? It flips upside down. 2's cancel. Negative root 3. Watch your signs carefully. That's a lot of what gets people. I mean, a lot of people do very well in this exam, but some people get stung a little bit because they're dropping negative signs. Be careful with that. Don't accidentally drop it, because a lot of times the answers will have both the negative and the positive. Let's go back and see. I don't know if it does. No. Oh, yeah, it does. Yeah, sure enough. See, there's the positive root 3, but we want the negative, huh? The answer's A, not C, on that negative root 3. So watch out. They usually have the same answer positive. So don't let them trick you. And I do mean them. I'm getting these off the publisher's test bank. I'm just the people that wrote the book. I'm just grabbing their. I'm just choosing which types, but they made all the multiple choice options and stuff. So they're trying to trick you. Don't let them trick you. Watch your signs carefully like that. Good on that? All right. Sine of 22 pi over 3. 22 pi over 3. That's a big angle, huh? Let's plug in the 180 thing. Pi is 180. This is sine of 22 times 180 divided by 3. So we have to, we got to do some by hand. Now, you know what would be easier is to divide first. Do the dividing, like 3 into 180. Do that first, then multiply, because dividing makes numbers smaller. So 3, you know 3 goes into 18 6 times, right? So that's 60. And then 22 times 60, right? Everybody see what I did there? I did the dividing first. You don't have to. I mean, you can multiply first, but dividing makes numbers smaller. So it's a little easier to divide first, then multiply. It doesn't really matter what order you do it in. So now I need to go 60 times 22. Well, the easy way to go 60 times 22 is just to do 6, and when you're done, throw a 0 on there, right? So let's go 6 times 22. 6 times 2 is 12. 6 times 2 is 12, add 1, 13, and then throw on a 0. So this becomes sine of 1320. 1,320 degrees. Everybody see what's happening there? Is that okay? I divided first and then multiplied afterwards. And the way I multiplied 60 is I just multiplied by 6 and then added a 0 at the end. 1320. Now what do we do with 1320? Bunch of 360s. Right? Do you all see what I'm doing on these problems? So I'm doing like one of every type. I did one with a huge angle, a couple with negative angles. I did 1 or 2 sines, like sine and cosine, and then I did a couple of the cosecant secants where you got to remember. So I'm just giving a variety of everything to make sure you can handle all the different weird stuff we did. So yeah, now just start subtracting 360s. So a bunch of them probably. So we got to do this by hand, a little painful. So 360. Oops. So what's that? 3, put a 2, put a 1. Remember borrowing and all that? 12 minus 3, 9. 960. Remember all that stuff? Minus 360 again. That'd be 0, 0, 600. Minus 360 again. 0. 6, put a 5, put a 1. 4, 240. There we go. Now it's an angle we can deal with. So this is the sine of 240 degrees plus a bunch of extra 360 rotations. So just subtract a bunch of 360s, get it down to 240. So now we want to draw ourselves, let me get over here and draw ourselves a unit circle. So we want the sine of 240. Where's 240? Let me give you a second. Go ahead and try that one. Give everybody a chance to find it on their own. Go ahead and try, and I'll give you a second. It's a good exercise. Make sure you can do that. We're finding this one okay. So 270's here, right? So 240's almost there. You with me? This is 180, 90, right? Every quarter turns 90. So 90, 180, 270. So 240 is just off the 270. It's really close. It's right there, isn't it? 240. We good? So what does that mean then? That means it's back a little bit, down a lot. Because it's close to the 270. It's not in the middle. It's not a middle guy. So the three numbers, small, medium, large, I'll put them up here again. Root 1, root 2, root 3 over 2. Small, medium, large. That's back the small, down the large, isn't it? To get to 240. So it's back a half, down root 3 over 2, cosine sine. What do we want? Sine. That one. That's it, done. Negative root 3 over 2. Here's our answer. It's the sine value, right? Cosine sine. Good. Questions? So Kevin was asking a good question, number 4. Let's go back. See, number 4.
Because wouldn't it be sine over cosine, not cosine over sine?
Oh, it's cotan, not tan. Because tan, remember, is sine over cosine.
Oh,
And cotan is upside down to that. Yeah, good clarification. Yeah. Any other questions on this one? Let's go to part 2 then. Figure out the drawing. So, I don't think you can see it. Negative 7 pi over 6 is what it says right here. Negative 7 pi over 6. Figure out which one of those is the angle drawn in standard position. It's a good question. Kind of tricky. So at this point, you'll have your graphing calculator. Now we're not graphing, your regular calculator. We're on part 2 now. So you'll have your calculator with you. You can use your calculator. So it'd be easy enough to pop in a 180 on your calculator. And you'll get, this goes in there 30 times, you'll get negative 210. Real quick on your calculator. Okay, so negative 210. So which of those, what is negative 2? Let's draw it on a quick little unit circle here. Negative 210. So this is starting at 0. This is negative 90, negative 180. So it's right about there, isn't it? Negative 210 starts here and goes all the way to there. So a little past halfway. Which one of those looks a little past halfway?
D.
Yeah, see how D goes halfway and a little past? Whereas, B's going way past halfway, clearly. And C didn't even make it to halfway, neither did A. So it's D. Is that good on that? Not too bad? All right. Okay, so they're telling me R is 1.5, S is 2.25. So you want to have the formula on your 3x5 card. And what formula is that? S equals R theta. And I hope you have a little note by that, pointing to that theta and saying theta must be what? Radians. Not degrees. So there's going. So right now, if you're making a 3x5 card note, I would write S equals R theta, theta radians. Must be. So that's because see, I'm needing it. So basically, anytime I need a formula as I'm going through this practice exam, I would write it on a side paper or 3x5 card that you're gonna record it, that you're gonna need it on your 3x5 card. So yeah, I would keep it. I'd go 3x5 card. So right now we have what? Sine, cosine, tangent. Tangent is sine over cosine. And then the reciprocal functions. This is cotan, cosecant, secant. And then we have S equals R theta. That's arc. You want to write arc length or something. And theta must be radians on that. Okay, so getting back to it. So they're saying S equals R theta, so use that formula. S, which is 2.25, bonk, right there. 2.25 equals R, 1.5, times theta. Good, so I just plugged in the S, plugged in the R, and now I can solve that equation for theta. And that's what they want me to find. Find the radian measure of the central angle. Find theta, the measure of the angle. How do I solve that equation? Everybody good so far? Just took S equals R theta, plugged in S, plugged in R. How do you solve for theta? Theta said, I want to be alone. Divide, huh? Yeah, divide by the 1.5. Is it just 1.5 again? Yeah. Okay, I was going to use my calculator. But yeah, 1.5. Just use your calculator. Hey, wait a minute, I don't see it. 1.5. Are we doing something wrong?
No.
What's the answer?
E.
None of the above. Do you like that? Sorry, it's a perverse pleasure, really, that I take in. No, yeah, I know it's kind of disturbing, isn't it, to not see your answer there. But there are some none of the above answers, like 3, 4, or 5 of them will be none of the above. I'm doing that so you're just not guessing your way through, right? It keeps you honest that you're really solving the problems and you're really finding out. Sometimes it's not there. So as long as you're solving the problems, you won't have any trouble. You'll know, well, it's not there. None of the above. You don't want to get like 20 none of the above. That's a problem. That's not the case, right? Good. We'll move on. Convert the angle in degrees, number 9, to radians. Okay, so how do we, here, I'll get a negative 54 degrees. Convert it to radians. What do we do? Get your calculator at this point. This is part 2. Yeah, so we got to do the pi 180 thing, huh? And how do you know which way it goes?
So you have to cancel the degrees.
Good. It's all based on what you want to cancel. You guys will be ready to go when you take Chem 3A. This is what I learned. The first thing I learned in Chem 3A is you put the 180 down below, degrees will cancel out, put the pi on the top, huh? Units, you're motivated by what you want to cancel. So then just use your calculator. Just take, so this becomes negative 54 pi over 180, and then just take a divide top and bottom by like what, 2? So negative, what's that, 25, 27 pi over 90. Now that reduces again, how, what else goes into those two? 9, yeah, divide them both by 9. And you get minus 3 pi over 10. Yep, there it is, D. Everybody see what I did then? So I just took the 54 degrees multiplied by pi over 180. I made it 54 pi over 180, and I just started reducing the fraction. Divide top and bottom by 2, divide top and bottom by 9, until I couldn't reduce it anymore. Minus 3 pi over 10. Good. You guys are going to ace this exam, right? This isn't too bad, hopefully. All right. All right, find a positive angle less than 360 or 2 pi that is coterminal with the given angle. Okay. Yeah, we did some of these. By the way, if you notice, these are all just homework problems, aren't they? Remember when we did coterminal? I remember talking about that with you guys last week or the week before. I don't remember which. But remember we talked about coterminal and what that word means? What does that mean when they say coterminal? Yeah, with and terminal ends, so it ends with it. So it ends in the same place, in other words. So basically they're saying, hey, what angle is really the same angle, ending in the same place as this one? That's basically what they're saying. What's the same angle? Said more simply, said positively, right? Find a positive angle that's the same angle. That's basically what they're saying. So yeah, so first off, what do they even mean? If you want to put something on your 3x5 card for that, then do so. If you feel like, no, I got that, then great. Whatever you need. So if you want to come over here and go, coterminal means same ending, same ending angle, whatever. So they say find a positive angle less than 360 that's the same. That's what they're saying. So take negative 3 pi. The pi is 180. You know that deal. So I'm going to take the pi and put in 180. Hit the buttons on your calculator. So 20 minus 260. Minus 260 degrees on that. Oh, I'm going to degrees. I don't have to go back to radians, huh? I mean, you could. It's okay. Either way. So I converted it all degrees. It might be easier just to stay in. I'll do both. Maybe I'll show you both. So I went to degrees. So now, what do I do from here? So everybody see what I did? I just took the pi, put in 180. Now what do we do? Add 360s, right? Yeah, just add some 360, just one 360. So it'll take it 100 degrees. Now that's the answer, but we got to change it back to radians now. That's why this method's a little bit of a pain. I'll show you how to do it direct in radians in a second.
You have to multiply it by pi over 180.
Yeah, so now you got to take that 180 and convert it back. So yeah, we got to put the 180 in the bottom. We want the 180 to cancel, the degrees to cancel now. Get those to cancel. And put the pi in the top. So it becomes 100 pi over 180. And then we can reduce that, divide by, what, 20?
Yeah.
Yeah, good idea. I heard you all say it. So I was going to do 10, but 20 is better. Good. 5 over 9. Is it negative? I didn't lose a negative. No, it's positive. I made it positive when I add that 360. That's right. So 5 pi over 9. Yeah, there it is, 5 pi over 9. So that might be the easiest way for you. I'll show you how to do it direct. That would be quicker if you're comfortable with it. If you took the other direct way where you don't have to go to degrees, you can just do it in radians and done. What would be that way? What would I do with negative 13 pi over 9 if I wanted to just stay in radians? Just add some 2 pi's. Yeah, because adding 360 right here, that's the same as 2 pi radians, huh? So you can just add 2 pi. Now, how do you take minus 13 pi over 9 and add 2 pi? Well, you put it over 1 and, you know, common denominator, huh? We got to multiply top and bottom by 9, don't we? So we get minus 13 pi over 9 plus 18 pi over 9, which is 5. Yeah, that's a little quicker, huh? Yeah, 5 pi over 9. Don't have to go to degrees and then back, you know, whichever you're comfortable with. I think you'll have time for either one. Most people finish the exam pretty early. Not everybody, but most. Good there? All right. We've been doing last 2 weeks. Secant of theta. All right, so see what you can do. Rather than me just whip it out, I think you'll get more out of it if I let you go first. See what you can do to find the secant of theta there. Okay, so let's give it a try. What do you do on this one? How do you find the secant? Oh yeah, we gotta do that first. I wasn't even thinking about that. You're right. We do gotta do Pythagorean. I was thinking about SOHCAHTOA. We gotta do SOHCAHTOA in a minute, huh? But you're right. First we need that hypotenuse, so the Pythagorean. You're right. So a squared, or I'll scribble it over here maybe. A squared plus b squared is c squared. The a and the b, it doesn't matter. You put the 10 first or the 7, whatever. It's just this is the c, huh? The c is always the hypotenuse, the one that's crossed from the right angle. Whereas the a and the b touch the right angle. I think you know all that. 100 plus 49, c squared 149, c squared root it. Root 149, that doesn't simplify. Nope. So just root 149. So there we go. Yeah, now SOHCAHTOA, huh? To find the secant, we got to do the SOHCAHTOA thing. So that'd be, yeah, so going back to your 3x5 card, I don't know if you just like know the Pythag super well already or if you want to put it on your 3x5 card. So I'm just making my 3x5 card as I solve problems. Go, oh, I needed the Pythag there. Oh, I also needed a SOHCAHTOA. Maybe. Or maybe you're like, I got that. I don't need to write that down. Whatever. Whatever you need to be different for everybody. But those are things we have used so far, right? All right, getting back to it. So, SOHCAHTOA, what are we doing? We're doing secant. And what's secant? Upside down a cosine, huh? Yeah, it's 1 over cosine. So cosine is adjacent over a hypotenuse. So then secant will be upside down that hypotenuse over adjacent, right? Hypotenuse, so hypotenuse, root 149 over, now adjacent, which one's adjacent?
10.
Yeah, because here's theta. Adjacent means next to it, right? Like your neighbor lives adjacent to you. So this is the adjacent. This is the side opposite, and this is the hypotenuse. So the adjacent is the 10. Yeah, root 149 over 10. There it is. We got it. Good? Questions I can answer? All right. So cotan. So remember, tan is sine over cosine, right? Tan is sine over cosine. So cotan, upside down to that, cosine over sine. So let's grab the cosine. 2/3 over the sine. Don't forget that negative. Negative 5 over 3. Like that? Just like that, right? Tan is sine over cosine. Cotan is upside down to that. Cosine over sine. Grab the one in the bottom, flip it up, because dividing is upside down, multiplying. So let's go times negative. Oh, whoops, I did the root in the wrong one. 3 over root 5. Right, just flip it up like that. Up it goes. These 3's cancel. Negative 2 over root 5, like that. We good? So negative 2 over 5. And then how do we get rid of the root from the bottom? You know, multiply top and bottom by root 5. Minus 2 root 5 over plane 5. Root 5, root 5. Plane 5 minus 2 root 5 over 5. There it is. Answer A. This is such an easy exam, right? Maybe. Well, it's easy for me, but I teach it day and night. Hopefully it's making sense for you. If you're having trouble, see Miss Wendy. She'll help you. All right, number 13. Calculator. All right, want to try it? Hit the buttons on your calculator. Number 13, secant of pi over 5. So give that a try. Let me let you do that. Rather than me say anything, let me give you just a second to try that on your own. The decimal answers are there. So use your calculator. Secant of pi over 5. Remember, there'll be no cell phones Wednesday. You can't, because you could, text your friends for answers. So I can't let you use your cell phone. So you want to have some kind of calculator with you. Doesn't matter what kind, but not a cell phone, right? So make sure you have a calculator in which you know how to change modes and do different things on. If you've been doing this on your cell phone all along, and then you show up with a brand spanking new calculator on Wednesday that you've never used before, that would be hard. That'd be like showing up at the ball game with a new pair of cleats. You want to practice with the glove and the cleats before the game, right? So make sure whatever calculator you're going to use on Wednesday, make sure you know how to operate it before Wednesday morning rolls around. So we don't have a secant button on our calculator. Most of them. So what are we going to do? The cosine. Yeah, because it's 1 over cosine. Exactly. And what mode do we got to be in? Is that a degree or radian? That's a radian angle. So make sure you're in radian mode. So get your calculator into radian mode. If you don't know how to do that, grab me after class. I'm glad to help. Each calculator is a little different, so I can't really let everybody know at once. They're all a little different. Most of them, it's like a mode button or something. They vary, though, a little bit. So go 1 divided by cosine and use the pi button. Find out where your pi button is. Again, I'm glad to help. Wendy can help as well if you don't have time with me after class. I'm getting 236.
Yeah.
Is it not there?
You have to round it.
Oh, round. Oh, yeah, it says round to 2 places. Remember, you circle the second place, look 1 to the right. 1.24. There it is. Rounded to 2 places. You able to get that in your calculator? 1 divided by cosine of pi over 5 in the radian mode. Questions in general on that? So if you can't get that, grab me or Wendy. I have 10 minutes after. All right, I'm going to move on. Okay, a straight trail with a uniform inclination of 16 degrees leads from a lodge, elevation of 500 feet, to a mountain lake, 9,700 feet. What is the length of the trail to the nearest foot? Okay, I was just about to just crank out a picture. So the triangle will look like this, in other words. So here's the trail. And you can make it go up, left, or right, whatever. But it goes from 500 feet up to 9,700. So that means this is a climb of 9,200 feet. Right? They're going on a trail like that at 16-degree inclination. And the trail's going up a mountain. Right? They're climbing from 500 feet up to the lake at 9,700 feet. So they climbed 9,200 feet, didn't they? Does that make sense on that picture? So you don't really need these anymore. You just need the 9,200 feet. That's how much they went up vertically, going from the lodge at 500 to the lake at 9,700. They rose vertically 9,200 feet. At a climbing along a trail, a diagonal trail, a trail going up a mountain, at an inclination of 16 degrees. So now what's their question? What do they want from me? What is the length of the trail? So they want this, call it X, or whatever you want to call it. That's what they want, huh? It's the length of this trail, the length of that side of the triangle. It's a right triangle, because because I made it go straight over and straight up, so that makes that a right angle. Good to there? So I came up with that picture. So now, again, let me give you a second. I imagine most of you can do it from here. Now, do a trig thing. All right, so what trig thing do we do? What trig, SOHCAHTOA, thinking about the different trig functions, SOHCAHTOA. So, let me write this over here. SOHCAHTOA. And what trig relationship involves the angle, the 90, 200, and the x? So I don't want to use the bottom because I don't know anything about the bottom of the triangle. But I know the 90, 200, and I want to find the x, and I got the 16. So what trig relation involves, what are those? This is the adjacent side down here. This is the opposite, and this is the hypotenuse. Like that. So what trig relationship involves the opposite and the hypotenuse? Sine involves opposite and hypotenuse, doesn't it? See that? So therefore, the sine of 16 degrees is 90/200 over x. Opposite over hypotenuse. Opposite over hypotenuse. Sine is opposite over hypotenuse. Is that good to there? Now, we got to solve that for x. How do we solve this little deal for x? What do we do? Yeah, remember cross multiply, put the sign over 1, go diagonal, diagonal. Remember how that works? So then you get x times the sine of 16 degrees is 1 times 9,200. Just diagonal, diagonal, cross multiply. You just put the sine of 16 over 1. Last step to get x alone? Divide by the sine of 16, yeah. So divide by, so 16 divide by, boom. There it is. X is 9,200 over the sine of 16. Use your calculator now. Well, what mode you got to be in? Now you got to go back to degree, huh? So be really careful with that in your calculator. Be paying attention. As you take the practice exam, make sure you're getting good at remembering to change back to the modes. This is back to degree mode here because this is a degree angle, 16 degrees, right? And 200 divided by sine of 16. I'm getting x equals 33,377. It says nearest foot, so I'm not going to do any of the decimals. Oh, yeah, there it is. Answer C. That's how long the trail is. So everybody see how I finished that up? So I drew a picture, and a climb was 9,200 feet. Want the trail, which is x, the diagonal. So SOHCAHTOA, opposite hypotenuse. So sine of 16 was the opposite over the hypotenuse, huh? That's what the SOHCAHTOA is representing to us. Then I just cross multiplied to whenever you have a fraction on one side, you cross multiply and then divide by the sine of 16. Questions on that one? Is that good? Like you can do something like that. So they're going to be one. It won't be, when I say the exam is similar, I don't mean it's going to be those exact words and I just change the numbers. That'd be silly, right? But there'll be a word problem. So there'll be a word problem that becomes a triangle. It could be totally different word problem, but it'll be a word problem that becomes a triangle that you draw and you use one of the SOHCAHTOA ones. So that's what I mean by similarity. I'm not going to give you the exact mountain and the lodge, and to me that would not be faithful teaching because you wouldn't really have to learn the concept. You could just monkey see, monkey do. No, you have to learn how to solve. So when I give you this, if you feel like, if you did this and you feel like, wow, yeah, I got that one now, but I don't know if I can do it, well then go back to the homework and do a couple more of those word problems. I don't know what section that came from. 1-3, 1-4. Look back to the homework and do 3 or 4 of those other word problems we had like that. It's going to be one of those kind. Does that make sense what I mean when I say the real? There'll be 20 questions on the real exam, 6 on part 1, 14 part 2. There'll be, one of each of these types, but it won't be the exact same words, right? On that. So practice the other word problems if you need to. Okay, so cotangent is negative 7/4. So 15. Negative 7/4. And what else will you be? Cosine is less than 0. Less than 0. What else did I say? Find cosecant. Okay. So there we go. Yeah, this isn't easy. So let me give you that. Let me give you a minute on that one as well. These are getting a little harder now. Give you a second. Okay, I'll get rid of that other stuff. We're in the second quadrant. So when I draw my triangle in the second, remember how this? You start at the origin, right? I don't go like that, for example. I've seen students do it in the past. That'll mess you up. That is a triangle, but it's not the way we need to draw them to make the values correct. We need to start from the origin and go out. Doesn't matter. I don't know right now, where it is exactly. I'm just going to go in the middle. I'm just guessing. But now, which way do I go to finish the triangle? Over or down?
Down.
Down. Why down? Why don't I go like that? Has to hit the x-axis, doesn't it? It has to be all about the x-axis. Yeah. So let me give you a reason for that now. I know I said I would, and I never did. Let's go back to, where's my unit circle one? Somewhere here. Almost there, I think. Yes. All right, look at the unit circle with me for a second. Let me show you why you have to go to the x-axis now. X-axis is called reference angles, huh? It's with reference to the x-axis. Look at the unit circle for a minute. Notice how anytime you're off the x-axis by the same amount, that the trig values are the same other than the plus or the minus. The numbers are the same, although the signs might be different. So for example, if you're at 30 degrees, the cosine is root 3 over 2. It's the big one, huh? And the sine is the half. Well, that means if you're at any 30-degree reference angle, you're going to have the same cosine and sine numbers other than the positive and the negative. Like, what's the 30? Let's go to the second quadrant. Here's the second quadrant. What in this quadrant? What angle has the same reference angle as 30 degrees? What's the 30-degree reference angle in the second quadrant? 150, because that's 30 off of the x. Not this one, not 120, which is 30 off of the y. Not him. It's the 150. And look at the 150. Look at his cosine. Same number, huh? Other than the plus or minus, right? The signs are different. See the sign? Same number, huh? Whereas if you did the 120, if you did 30 degrees off the y-axis, the cosine would reverse. Wouldn't be right. Why? Because 0 degrees is where they all start, huh? So everything started from the x-axis. So if you want to get the same trig values in other quadrants, as long as you come off the x-axis the same amount, you're going to get the same over and up kind of thing. Same cosine and sine. Same thing in the third quadrant. What's the reference angle of 30 degrees in the third quadrant? 210. Because that's, again, 30 off the x, huh? So if you're off the x-axis by the same amount, you're the same as just the first quadrant values other than signs. Say the cosine, sine, same thing, huh? What's 30 degrees off the x-axis in the fourth quadrant? 330, right? Not 300, not off the y, huh? Always off the x. If you go off the y, you get them backwards. Cosine, sine, same values. Do you see that? That's why we're into these reference angles, because you're going to get the same trig values. And if you get the same sine and cosine, all the other four are the same, because they all come from sine and cosine, don't they? So if we're at a reference angle, we're going to have all the same trig things other than the signs, and we handle that with all students take calculus, the plus or the minus, but all the same numbers for all the trig functions. If you're the same amount off the x-axis in another quadrant, you can just pretend you're in the first quadrant. Just do the trig stuff there, and then fix your plus or minus. See how that works? See the idea behind it? And why is it always the x-axis? Because that's where the whole thing started. They put 0 degrees at the x-axis. So all the angles really are coming off the 0 degree x-axis. Even like 300 comes originally from the 0 positive x-axis, huh? Why did they do it that way? I have no idea. They could have made 0 straight up like a clock, but they didn't. They started on the x-axis, so all of our reference angles are always to the x-axis. All right, so getting back to it, you've got to make this to the x-axis, not to the y, or you'll get backwards answers. Okay, so remember how this works now? How do we put the information on there? They're telling me we do SOHCAHTOA, don't we? So remember SOHCAHTOA, here's my angle to the x-axis. See, that's not really the angle, is it? Really the angle's from here. But whatever, it's the same thing. As long as you come off the x-axis, you're going to get the same trig value. So I'll just put it right here, off the x-axis, in the second quadrant. So SOHCAHTOA, they're giving me cotan. Tangent is opposite over adjacent. So cotan upside down, this must be adjacent. Oh, not over hypotenuse, over opposite. Right? See how I'm coming up with that? That's good. So I drew it in the second quadrant. Then I said, okay, SOHCAHTOA, tangent's opposite over adjacent. So this is upside down, cotan, adjacent over opposite. So now this is adjacent side, opposite. This is the hypotenuse from that angle. So adjacent minus 7 up 4. Back 7 up 4. Adjacent is back 7. Adjacent is back 7. Opposite is 4. Opposite is 4. Now, how do you know the negative isn't really on the 4? Well, it's because it's back and up. Huh? It's negative and up. But remember, if you want to just ignore those signs, just put 7 and 4 and forget about the negative, you can do it, and then at the end, just make sure it's right by the all students take calculus. It's your option. That's how my daughters always wanted to do it. Whichever way. All right, so let's figure it out. Now, we got to find the hypotenuse by the Pythag. These are kind of long problems. So a squared plus b squared is c squared. The hypotenuse is the c. The other two, the order doesn't matter. 4 squared plus negative 7 squared. 16 plus 49. What's that? 65? Yeah. Good. And then root it. So root 65. That's not simplifiable. Is that a word? Can't be simplified. If you break it down, it's just 5 times 13. There's no pairs there. Nothing rootable. So root 65. So now we're ready to go. What's the question? Cosecant. What do they want from me? They want cosecant. So how do I find cosecant? So the cosecant theta. Now what is cosecant upside down of? Sine. Sine is 1 over sine. Sine, SOHCAHTOA. Sine is opposite over hypotenuse. So I need hypotenuse over opposite, don't I? Mm-hmm. Upside down of sine. Right? Sine's opposite over hypotenuse. Cosecant's upside down of that. Hypotenuse over opposite. Hypotenuse. Root 65 over opposite. 4. Now, careful. Double check the sign. I mean, I'm thinking positive. And it turns out it's right. But double check. You wouldn't want to do all that good work. Because I bet you, let me see, if I know these publishers answer things, I bet they have the negative also, don't they? Yeah, see, there it is. Is it? Wait, I'm totally confused now. Which one is it? 6 over 4. Okay. So it's either that one. Oh, ours isn't even there? See, that's dastardly, isn't it? See, they made this. I just asked them for a triangle question and put it on the exam, slid it over from the test bank. So they make up these options. See how they're putting the negative version, right? Now you want to double check. You want to double check with all students take calculus. We're in the second quadrant. In the second quadrant, sine is positive, and his upside down cosecant. Yeah, it should be positive. It should be positive. So I am not going to grab that negative answer. It's none of the above. They baited the hook and threw it in the water for us to bite, huh?
So, since we did like the triangle and everything in that quadrant, wouldn't we already know that it's positive?
Yeah.
So would it ever be like we do it in that quadrant and it's not?
No, you're right. Back when we first did it, I was thinking about saying something then. Like, hey, we know it's got to come out positive because we're in the second quadrant, sine, and his upside down, cosecant is going to be positive. You're totally right. Yeah, good observation, Presley, right? Yeah, you're totally right. We knew right then it was positive, and that could never change.
Okay.
Yep. Is that good? So always double check. So a lot of people really know what they're doing and they just get a few signs wrong, and that's frustrating. So check your signs carefully. Yeah.
If it said find set, like
Secant, yeah.
then it would still be up in that quadrant, but then.
Right. So yeah, what if they ask for secant? Yeah, let's just do it. Secant would be upside down to cosine, huh? So that'd be hypotenuse over adjacent. So that'd be, yeah, same quadrant, same triangle, same everything, just different ending. Be hypotenuse, and adjacent then would be -7.
Okay. So
Yeah, and it is negative because only sine is in the second quadrant and his upside down are positive. The others are negative, so secant would have to be negative.
Okay.
Yeah, exactly. We good with all that? Triangles are super important. Not only this exam, it's a whole grade on this exam. We'll do them rest of the course. You go to pre-calc, calc, they do them again. This is like the main thing they use in calc from trig is he's drawing these triangles. So let's spend time there. So find the reference angle for -13 pi over 3. Let me just give us more room here. -13 pi over 3. Find reference angle. Okay. What's a reference angle? It is a degree. Well, it can be a degree or a radian. I think this one has radian answers. But let me write some words. I think some words would help. I think having a real clear sentence in your mind will help. Does anybody have it already? What is a reference angle? Somebody stopped you on the street. That's not going to happen. But said, what's a reference angle? And you had to put words to it. What is it? What is a reference angle? Exactly, precisely. What is it?
It's the angle to get back to the x-axis.
Right. You're missing one important word. So Kevin was saying angle to the x-axis. That is very good. 99% of what we need to know. Just one other small thing. Like what if I was like right here, for example, at whatever that is. Let's say 210 degrees.
How far it is to get to the x-axis?
How far it is? That's still missing that crucial word. So like what if I was at 210, for example? What would the reference angle be? To the nearest. Because you can always go to the x-axis that way. Nearest. Now you probably assume like, I knew that. Well, whatever. As long as you know it. Nearest x-axis, right? So it's how far to the nearest x-axis. Because there's two x-axes. There's a positive one and the negative one, huh? So it's how far to the nearest x-axis. So anyway, so let's give it a try. So how do you take -13 pi over 3 and find out how far to the nearest x-axis? What are you going to do? Probably a lot of ways to go. Do you want to just stay in radians? We could try that. I don't know if you're comfortable with that. We could just, whatever you like. I probably may have better do it a couple ways. You can just start adding 2 pi's. Want to just do it that way for starters? We'll just try to stay in radians and see if we are comfortable with that. So yeah, first off, let's just start adding 2 pi's. Get down to like a normal positive thing we're used to, right? You can always add 2 pi. It doesn't change anything. So add 2 pi. Now, how do you add 2 pi? Right, make it 6 pi over 3, multiply top and bottom by 3, common denominator, so that's -13 pi over 3, plus 6 pi. 6 pi over 3 is a big fancy 2 pi, isn't it? Right, just looks different, add it up, what's that, -7 pi over 3, and then do it again. -7 pi over 3, add another 6 pi over 3, because that's another 2 pi. So then you get -1 pi over 3, let's do it one more time. -1 pi over 3, or if you're comfortable right then, there's no rules here. It's whatever like I can see it right now. I can see the answer. Can you? If you can see it right now, great. Write it down. You're done. If you can, once you get to -1 pi over 3, if you're like, oh, I can see it now. Great. Don't take any more steps. If you're not sure, you can add another 2 pi. What do I mean? I can see it. Maybe I should just show that. So what is -pi over 3? Well, I don't know, but it's down a little bit. Right? All I know is it's down, well, it's 60 degrees, isn't it? That's actually 180 over 3. Anyway, whatever. It's somewhere in this quadrant, this fourth quadrant, down 1 pi over 3, huh? Right? So, and what's the reference? What is the reference? Keep it real clear in your mind. How far to the nearest x-axis? How far to the nearest x-axis? So how far from here to here? Well, pi over 3, right? Right now you might say, well, yeah, but it's negative. No. If I said, how far down to LA would you go? -200 miles, because it's south, Mr. Heron. Nobody talks that way, right? No. When you say how far, you never give a negative answer, do you? No. distance, we always say positive. That's just our cultural thing. And so so they mean the same thing. That's why when I write how far to nearest, I should have said how far, I guess. How far, it's always positive. You always go to the positive. So positive pi over 3. That's how far. Right? If you're down pi over 3, you're pi over 3 away. So pi over 3 is the answer. Is it here? Yeah, boom. There it is. Does that make sense? It's probably the easiest way. I just added until I saw it. Now, if you added another 6 pi over 3, let's see what would have happened. I think it would have been harder for you to see. It's okay. You get 5 pi over 3. Yeah, do you know where 5 pi over 3 is? Maybe use the unit circle.
300 degrees.
Yeah, you could do that, or you could just look. Let me just go. Where is that? Let me grab the unit circle for you again, because you'll have that right on your 3x5 card. This. So maybe if you added another one, because I know a lot of people they don't stop at the negative right here. They just kind of keep going until it's positive, and that's okay. 5 pi over 3, and then you could just look. Where's 5 pi over 3? It's right there. Shrink this down a little bit. It's right here. And you go, oh, it's 300. How far is that? 60 degrees away. Oh, that's pi over 3. How about that? Is that okay? That's another way. Because what I've seen in the past is students, there's just a lot to remember, I know. And they get here and they don't realize it's real easy from there. They just kind of want to keep going until it's positive. And that's fine. And so if you added another 6 pi over 3, you get this. So I'm showing you how you would answer from there. If you got 5 pi over 3, then you would come in here and go, okay, where's 5 pi over 3? You'll have this on your 3x5 card. 5 pi over 3 is right there, which is 300, which is how far from the nearest. That's the main thing. You got to be crystal clear. You got to keep saying to yourself, I would write on my 3x5 card thing, reference angle, how far to nearest x-axis, and just be really, really clear on that. That's the main thing, Write that wherever I had that 3x5 card thing. I don't even remember now. Here it is. So reference angle, how far to nearest x-axis. So I think if you're crystal clear on that, you'll be good. So if you're looking, okay, 5 pi over 3 I'm here. But that's not my answer, because that's the kind of thing students do. They probably have that 5 pi over 3 answer there, don't they? Oh, no, they don't. Okay, usually they put that as one, and they're just trying to sucker you in. So, not that one. But anyway, 5 pi over 3, and you go, okay, but that's not my answer. It's how far to the nearest x-axis. That's what a reference angle is, right? How far to the x-axis. 60 degrees, which is pi over 3, 180 over 3. Right? Good? So either way, the eventual answer is pi over 3. Questions on that one? Okay, so they're giving me, make it a little bigger here. 5/7 comma minus 2 root 6 over 7. They want the cosecant. So remember, whenever you have a point on a unit, this says unit circle. This is cosine, sine. They're backwards, as you know. So how do we do cosecant? What is cosecant? 1 over sine, huh? Just grab that sine and give it a flip. 7 over minus 2 root 6. I just flipped over, that's a 7 down there. Just flipped over that sine. Cosecant's just upside down in sine. Flip it, can't leave a root on the bottom. Multiply top and bottom by root 6. Get 7 root 6 over minus 2 times regular 6, which is 12, huh? 7 root 6 over minus 12. There it is. Not bad, right? Cosine, sine. Cosecant, flip sine. 19. Theta is an acute angle. Sine's given. Use Pythag. Sine squared plus cosine squared is 1. Find the cosine. We can do that. So find cosine. So sine is root 5 over 3. Plug that in. Root 5 over 3 squared plus cosine squared is 1. Good so far. I just plug in the sine. Okay. Now, when you square that root 5 over 3, what do you get? 5/9. Everybody okay with that? Because you square the root 5, just becomes a regular 5, right? If you want, write two of them. That's what square means, huh? Two of them. Root 5, plane 5, 3 times 3, 9, huh? Good there. Plus cosine squared is 1. Now I'm trying to solve cosine. They asked me for cosine, huh? Trying to find cosine. How can I find cosine? How can I get cosine alone? Subtract the 5/9, then we're going to have to root it, huh? Subtract 5/9. Cosine squared equals 1 minus 5/9. And how do you do 1 minus 5/9? You know, make that 1 9/9. Minus 5/9 is 4/9. Write that a little better. 4/9. Last step. Root it. And what do you got to remember when you root something? Well, I don't know if you know that from algebra. Plus or minus. Now, what do we have plus or minus? Why is that? What did they say in this one? Oh, theta is an acute angle. Here, I'll explain that in a minute. So anyway, so that's what? Plus or minus 2/3, isn't it? Yeah, I don't know if you remember from algebra, when you root both sides, you got to put plus or minus. Really, you don't have to on this problem, though, because they said theta is an acute angle. What does that mean? So what? What does that mean it's an acute angle? Why do I care about that? It's just a cute little angle. What does that have to do with anything in this problem? What does it mean? Why can't it be negative?
Because it has to add up to equal 90.
Yeah, what does acute mean? Less than 90.
Yeah.
Less than a right angle. So that means it's where? First quadrant. If it's less than 90, it's in the first. And what do we know about the signs? All are positive in the first quadrant. So yeah, long story short, you don't have to worry about the negative thing. Later we'll deal with that. For now, don't even worry about it. 2/3 is the answer. Just don't even worry about any of that plus or minus stuff. 2/3. There it is. Number 20. Let theta be an angle in standard position. Name the quadrant. Oh, that's not bad, is it? So, all right, so number 20, they're telling me it's the all students take calculus on number 20. So they're telling me tangent is less than 0.
So it's not that one.
So it's not here or here, huh? Because they're all positive in the first, and they're telling me tangent's less than 0. That means tangent's negative. Huh? Right? Less than 0. That's negative. Tangent's negative. So it's not the first or the third quadrants. Try the second one. They're saying sine is less than 0, which means sine is negative, so it's not there. We're in quadrant 4. B. Got to know Roman numerals, though. Quadrant B, quadrant 4. Is that good on that? Questions on that? Shall we go back and do that one other triangle? All right. So secant of theta is 9. Here, let me just get some room here. Secant of theta is 9/4. Quadrant 4. Quadrant 4, find tangent. All right. Give that a try. Number 16. So these are the long ones.
Number 3 was not easy.
They're giving me quadrant 4. That's nice. So quadrant 4. Draw our triangle. We always go to the x-axis. Reference angles are the same. Angle's always right there at the origin, huh? Right. Notice I never put the angle like down here or something. It's always got to be at the origin to have the same values. So there we go. And then secant, so you got to remember our SOHCAHTOA. So SOHCAHTOA secant is upside down of cosine. So cosine's adjacent over hypotenuse. So this must be hypotenuse over adjacent. So hypotenuse must be 9. This is the adjacent side and the opposite side. So the adjacent is 4. So now use the Pythag to find the opposite side there. So find the opposite side with the Pythag. So a squared plus b squared is c squared. So which one's the c? The 9, because he's the hypotenuse, huh? The other two, the order doesn't really matter. So 4 squared plus b squared, so that's 16 plus b squared is 81. Subtract 16 from both. Is that what it is? 65, 7. Yeah, thanks. 65, and then root it. So root 65. Now, really, is it positive or negative root 65? If you want, you can ignore it and then just do the all students take calculus. But you can tell by the right, left, up, down, right? Right is positive, left is negative, up is positive, down is negative. So starting from the origin, this is right, so positive, and down, so negative actually, huh? But you don't, if you want to just skip that and just say, look, all students take calculus. Cosine's, I'm in the fourth, cosine's positive. What's tangent then going to be? Got to be negative. I know, right? Because cosine's positive and his upside down secant, but all the other 4 have got to be negative, huh? So you know this answer's negative. You can go back to the answers and say, oh yeah, they're all negative. So I was going to cross out the positive ones, but they're all negative. All right, that didn't help. So yeah, we know the answer's negative. So tangent, how do we get tangent then? It's, so opposite over adjacent. Opposite, root 65 over adjacent 4, but it is negative as we already saw. Negative root 65 over 4, A. There it is. Are we good?